Hi guys, sorry that you missed our class this morning. If you're watching this, it's just obviously to go over what we talked about. So I'm gonna skip around to some of the key things that we did today, so that way that you're ready for the work that you need to do on Khan Academy today, and then a quick drawing activity on a Google Doc. So we talked today just at the beginning about how to review and how to find probability. So the probability of each of these things, if you notice underneath my face, I've got sort of a blank sheet of paper. So I'm going to do my work there for what we're doing today. So the probability that something was blue, okay, we're going to just go with fractions here, was going to be 3 out of 12, okay, which reduces to 1/4, all right, which we know is 25%. The second one, probably that it's green or yellow, okay, we'd add those up together. We would get 4 out of 12, okay, which we know is a third or 33%. The probability that it's red, okay, is going to be 5 out of 12, and the probability that it's not red is going to be 7 out of 12, the opposite of that. Okay, so those were just some of the basics that we started with today. Okay, the best joke was awarded to Tagia, so she's getting her Google Play gift card. So our goals today, there's two things we're going to work on, is to be able to draw a tree diagram to determine the number of possible combinations of a given situation, and we're going to be able to use something called the fundamental counting principle to determine the number of possible outcomes of a given situation. So what we're going to do first, we're going to draw a tree diagram. So to draw a tree diagram, okay, the purpose of a tree diagram is to outline all of the possible combinations. So I'm going to go ahead and do this here so you can see hopefully a little bit better right now. And what we're going to do is, the first thing you do is you draw your brain. Okay, so you draw a little dot here. And then we read what we're choosing. So it says you're ordering a fruit smoothie. You have your choice of small, medium, or large, and you can include one of the following fruits: strawberries, bananas, or mangoes. How many different choices of smoothie do you have? Now, this one's fairly straightforward to come up with if you could think through this on your own, but the point of a tree diagram is to list out what the possible combinations are. So my brain first has to decide, okay, do I want a small, okay, a medium, or a large smoothie? So that's the first choice I have to make, okay? But once I've made that choice, then what I have to do is I have to think, well, if I got a small, I could get a strawberry, okay, or a mango, or a banana smoothie, okay? Now, if I order a medium, I could get the same thing. I could get a strawberry, okay, a mango, or a banana smoothie. And if I get a large, I can get the same thing: a strawberry, a banana, or a mango smoothie, okay? So what I've got now is I have my possibilities. I could order a small strawberry, I could get a small mango, or I could get a small banana. I could get a medium strawberry, a medium mango, and a medium banana, or I could get a large strawberry. Okay, so these are over here, these are our combinations. Okay, get a large strawberry, a large banana, okay, or a large mango. Okay, so what I've done there is I've used my tree diagram. This was the first decision I have to make, first choice, okay, and then this was my second choice. Okay, so what this says here is that there were 3 options for my first choice, and then there were 3 options for my second choice. And altogether, there were 9 total possible combinations. 1, 2, 3, 4, 5, 6, 7, 8, 9. So what if we did this by flipping a coin and rolling a die? Okay, so let's draw our brain, okay? And I'm going to flip a coin first. So if my first choice, okay, is a coin, that means there's 2 options for that coin. It can be heads or it can be tails. Okay, now my second choice is rolling a die, and I know that there are 6 options there. So what I'm going to do, if I flip a heads, I can get 1, 2, 3, 4, 5, 6 possibilities. If I get a tails, I can do the same thing. I can get 1, 2, 3, 4, 5, 6 possibilities. So the possible outcomes that I have are heads and 1, heads and 2, heads and 3, heads and 4, heads and 5, and heads and 6. Okay, and then tails and 1, tails and 2, tails and 3, tails and 4, tails and 5, and tails and 6. So there are 12 total possible outcomes. Now there were 2 options for the coin and 6 options for the dice. So if you're starting to notice a pattern here, what we're seeing is we might be able to do something with these numbers to be able to figure out how many possible outcomes there are. So if I asked you to do this, to draw a tree diagram for it, it says Mrs. King wants to buy some pizza. There's 8 different kinds of vegetables she can put on it, 3 different kinds of crusts, 7 different meats, and 4 different stores. How many possible combinations can she make? This would take a really long time to draw a tree diagram. You'd have your brain, and you'd have to make 8 different decisions to start with, 3, 4, 5, 6, 7, 8. And then each of those 8 would have to have 3 different lines coming off of it. Okay, and that's going to get crazy, all right? So what we need to be able to do is we need to be able to do this more efficiently, okay? So what we can do is we can use something called the fundamental counting principle, okay? So this is one of the key things that you need to know today. The first thing was to how to draw a tree diagram. The second thing is, what does the fundamental counting principle mean? So the fundamental counting principle means if an event has m possible outcomes. So if I flip a coin, okay, it had 2 possible outcomes. And then the second event, if I roll a die, it had 6 possible outcomes. To figure out the total number of possibilities, you multiply the 2 options or 2 possibilities together to get 12 in total, okay? So if we roll 2 dice, okay, what we can think about here is that first dice, so die 1, okay, has 6 possible options, okay? Die 2 also has 6 possible options. So that means together they have 36 total possible combinations, okay, that I can get. That assumes that a 1 and a 2, okay, are different than a 2 and a 1, okay, just for reference sake, okay? Now the reason this is going to be helpful is because what we're going to move into later this week is finding the probability of compound events, of things that happen at the same time. And this is going to give us the total number of possible combinations. It's going to be our denominator, okay? So we're not worried about that today. Today we're just worried about figuring out how many possible combinations. So here, how many possible outfits can you make from the clothing items below? What you're going to look at is, okay, I've got shirts to choose from, we've got pants to choose from, and we've got shoes to choose from. So how many shirts do we have to choose from? We have 3. How many pants? 2. How many shoes? We have 3. So we're going to multiply those together and get 18 total possible outfits, okay? What about this one? So there is ice cream that we're choosing, there's sauce, and there's candy. There are 4 ice cream choices and 4 sauce choices and 1, 2, 3, 4, 5, 6 candy choices. Multiplying all that together, you get 96 total possible candy combinations, okay? So the last thing we talked about in class today was kind of applying this to telephone numbers, okay? This is beyond what you need to be able to do. So if at this point you get what you're doing, you can go ahead and move on to the assignment. But basically the sort of the connection here is when you think about a phone number, in the US it has 3 digits as an area code, so these are usually in parentheses. And then you've got the first 3 digits of the phone number and then the last 4, okay? So when you think about a phone number, there are tons and tons and tons of phone numbers that are possible, but there's also some rules about what numbers can be in each of those spots, okay? If we think about the numbers 0 through 9 as all the possible numbers that can go in an individual spot, no phone number, no area code ever has a 0 or a 1 first. So that means there's actually only 8 options here. You can go 2, 3, 4, 5, 6, 7, 8, 9, okay, as the possible numbers to start there. Here though, the second number, you can have 10 possible numbers, okay, 0 through 9. Here you can have 10 possible numbers, 0 through 9, okay? Now, this number here probably doesn't start with a 0, okay, but it could start with a 1. So we'd put 9 there. There's 9 possibilities, and then 10 and 10, and then 10 the rest of the way, okay? So the idea with this is just to show or to indicate a little bit of how this idea of fundamental counting principle helps you understand a little bit more what you're seeing or why there's so many possible combinations. Think about the lottery. Okay, if there's 20 numbers you have to pick, if there's 10 possibilities in each of those spots, no wonder nobody ever wins. Okay, or no wonder it's so rare to win. Okay, so your work today. Let's see if we can do this. Okay, your work today. You're going to go to the Canvas page for today. Has all of this listed here, so don't stress about that. But you're going to do 4 quick questions about the counting principle on Khan Academy. So that's listed. There's a link on the Canvas page for that today. And then the next thing you're going to do, there's also a link on Canvas for a copy of what's called a Jamboard. And a Jamboard basically is a Google Whiteboard. Okay, and you're going to look at the first example is done for you, and then on the next 2 slides or cards, you're going to draw the tree diagram that fits for that situation. So to draw, there's a little pen on the side. So you just click that, and then you can draw lines and text and whatever else you want. Don't worry if it doesn't look beautiful. That's okay. Mostly I just care, do you draw the tree right? Okay. So you'll submit that on Canvas. There's been a couple issues with submitting it. If you just if you click on share and get the link, you can share it that way with me. If you want to just share it and search for me and say share with Haley King, that's fine too. Doesn't matter to me. But you can submit it on Canvas that way. So that way we can have it all wrapped up. As a reminder, there are help sessions that are running every day this week from 3 to 4 p.m. The link's on Canvas. You just join it if you need help. Right now, they're not very well attended. So if by Friday they're not more well attended, and that's fine, then we'll go down to this Monday, Wednesday, Friday next week. Okay. Also, our team is having a Zoom chat every Tuesday from 1 to 2 p.m. Okay. Once per week, Miss Torres sends out the link for that, and I'll also send out that link so you can see it too. So I hope you guys are doing well, and that next class you'll be there. But if you weren't there today, no worries. Try to work on this and send me an email or join the help session tomorrow if you need help on what you're working on. So take care and see ya.